Today we're recapping lesson 4.7 on isosceles and equilateral triangles for those who had their off day on Thursday, so mods 5 and 15. The notes are already filled in from mods 1, so I'll just be recapping important things you need to know for test of chapter 4, which is coming up. So first off, the main two theorems we had in this lesson are base angles theorem. And what base angles theorem says is that if we have equal sides of a triangle, opposite of those equal sides are going to be equal angles. So in this case, AB and AC being congruent or equal will give us angle B congruent to angle C. So basically, isosceles triangles have also two congruent angles, right? Now the converse is equally true, and the converse of that is using base angles being congruent, right? Angle B and angle C congruent. Given that, we then know AB and AC, the sides opposite of those angles, are equal. And so now, if we have two angles congruent, we know that triangle is isosceles. And because equilateral is also in the mix, this works for three sides. So remember that isosceles triangles were triangles that had at least two sides congruent. Equilateral triangle technically is an isosceles, a type of isosceles triangle, right? Because it has more than two sides congruent. It has all three. So it works just the same as the other one. If we have two sides congruent, then we're going to have three angles congruent, right? So in this case, we've got three sides congruent. Their opposite angles are congruent, which means we've got basically an equation that says 3x is 180, right? Because x plus x plus x, they're all the same measure, equals 180. That gives us 3x. And divided by 3, we get each angle of an equilateral triangle is 60. Now, the corollary to the base angle, we won't use the name like that. But if we see a triangle that has three congruent sides, we know the angles are all 60. And if we see a triangle that has three congruent angles, we know that it is equilateral. That is what that is telling us. So we did some basic solves. If you want to look in your book to kind of solve these yourself, they gave us one side is 5 and the angles are congruent. So we marked up the other sides being congruent, and that meant they all equal 5. Down below here, we did the same idea. We had, again, another equilateral triangle here where all the angles are congruent, so all the sides are congruent. So y equaled 4 wasn't really a solve. We just, figure that out. They were equal. And I marked all three sides because down here we've got a two-angle, angle 2 for arc marks. So 4 and x plus 1 must be equal. Subtract 1 from each side to solve for x is 3. Next up, we have, we'll go through this one piece at a time, so even though it was already given, we have these triangles. Originally it was a picture of a couple of a kind of a lifeguard chair, but given we had PS congruent to QR, QPS congruent to PQR, what congruent postulate would we use to prove QPS congruent to PQR? Now they're talking about, again, kind of this blue highlighted and yellow highlighted triangle. And just looking at the picture, we do have a little bit of green, which means we would have a reflexive. Both triangles are using PQ. And sometimes in this case, it's hard to see. So I redrew the triangles here, right here, separately, and labeled what we had. Well, we had angle 1 and angle 2 are not congruent yet, but we'll be a little bit. Let me relabel in red what they gave us because we marked some things for CTC. We had reflexive, and they gave us PSQR. So these sides, so these were equal. And then the last thing they gave us was the large angles. So they gave us these angles in red. So looking at that, we had side angle side, side angle side on both of those. So side angle side was our congruence postulate. Next question was, why is that small inside triangle isosceles, right? We kind of got the answer there, but why is this little guy in the middle with the green base and angle 1 and 2? Well, basically, we just started filling in what we needed. So again, it was already filled out, but here, this angle 1 and 2 are congruent by CTCTC. right? So 1 and 2 congruent because the triangles were congruent. And now we've got 2 angles congruent in the small triangle, therefore base angles converse, right? Converse, we use the base angles to show the sides are equal to give us PT congruent to QT, and therefore we've got base angles converse there, but we've got then an isosceles triangle. The last one was how would we show PTS congruent to QTR? Now those are these inside triangles right here. So I just drew them out, filled in what we had, and it was kind of a different one because we had so much information, but it was a lot of side-side angle. So using vertical angles, we had some information using CP/CTC from step 1 up here. We had angle 3 and 4 congruent, so I labeled those. This is technically angle 3, angle 4. We had our verticals right in the middle. And then we've got angle, side, angle. We could also, angle, angle, side. We also could, again, go with extra steps to find angle, side, angle, but the shortest way was angle, angle, side. So that was originally going to be kind of a long, complex proof, and I just kind of broke it down into the main key concepts of it. Next up, solving for x and y, and again, these are kind of already solved for you. So see if I can at least give us the guts of it here. But we had this triangle over here, and it was all these sides are labeled congruent. So then we knew all these angles are 60, so x equals 60, right? X right here equals 60 is pretty straightforward. But then what are we going to use with that, right? We have the right angle box. So if we know this is 60, right angle box is 90, this angle is 90 minus 60, right? Math right here to give us 30. And then 30 plus 30 is y, giving us 120. Moving on next, this one down here just kind of talk through how we could solve all the angles. I'll kind of leave it up there so you can see. But with all these congruent marks, just given one angle, we can figure out the other 2 angles of a triangle, right? So if we start with 50 degrees here, isosceles tells us this angle equal, and 180 minus 50 minus 50, or 180 equals x plus 50 plus 50, would set us up to solve for triangle sum theorem, and then minus 100 for both sides to get that angle with 80. On the right side, we had equilateral over here. All 3 sides congruent, all 3 angles are 60, and then our last piece was using this straight angle here. We had 50 on one side, 60 on the other, so 50 plus 60, and I called the missing angle y equals 180. Subtract 110 from each side, we got that angle of 70, and our last missing angles were 70 plus z is 180, z ended up being 55. Now we had another proof, but the whole point of this proof, again, trying to slow down from the proofs of chapter 4, is how are we using base angles theorem in the proof, and how it ends up being is they gave us some information on the small triangle, but with that information, it gave us base angles congruent, and then if you look at the larger triangle, we then have angle, angle, side, and then over here, angle, angle, side. So we basically just need we didn't need congruent triangle. That was our 4-step solve. That was an option. However, what are we proving, right? I was thinking about the triangle being congruent. We only needed the angles congruent. So if we had 2 angles of the 3, right? I've got 2 angles of the 3. We just need third angles theorem. So that's the thing that you got to be careful about, because I ran right into the mistake of, we've seen so many triangles, how are the triangles congruent? It's kind of right where my mind went. Would that have still worked? Yes, but it would have been 4 steps, right? Triangles congruent would have 3, 4 would have been CP/CTC, when instead the triangles already had 2 of our 3 angles congruent. So third angle theorem, again, shortest way possible to solve, tells you we have 2 angles of a triangle congruent to 2 angles of the other triangle, therefore our last and third angle is congruent. A little bit more tougher math solves here, not as likely to need to know these. You can peek at the notes to see how they were solved, but the general idea here was we had two exactly the same triangles, right? Those 2 congruent marks told you these both had to be x's, And so using something we haven't used before, but basically a whole circle of angles here, add to 360, and you won't need to know that, use that. But x plus 60 is 360, subtract 60, 300 is 2 of x is 150. Down here was a little more of an intricate solve. We had y here, x here, and then just a bunch of congruent marks, right? We have an isosceles triangle here and here. And knowing what we know about a triangle, I call this third angle z. Well, we've got z happens to equal 2 of x because of exterior angles. This angle's exterior equals the other two opposite non-adjacent angles added together. So x is z plus z, 2z equals x. So these angles, I solved for z so that I could write them as x. This angle over here is x half. This angle over here is x. X plus x half equals 90 degrees. Do a little bit of a complex solve. 3/2 x is 90. What is 1x? 2/3 times both sides gives you 60 degrees for x. And then 60 plus what is 180? Y gives us 120. Last proof here was just to note how we've had some of these prove triangle congruent. And again, I did edit this. That's what the 2 stars mean if you printed out notes. But the general idea is we've had a couple of these where, oh, we've got something congruent, prove sides congruent. Well, now we can use base angles converse. And this is how I would write it out, right? If we have these angles congruent, opposite sides are congruent, and they might even split it up to look like congruent triangles, but just because we know how to do that doesn't mean you have to do that every time. And then the last slide was, as a reminder, don't forget that just given real basic information now in an isosceles triangle, we can, given one angle, solve the other 2 missing. Homework is still expected to be done. However, the due date has changed due to this online learning. Feel free to email me if you have any questions. Thanks.